All right, Algebra 1, Section 7.3, notes. So, Algebra 1, notes. This is Section 7.3, special products of polynomials. So we've been dealing with polynomials so far in Unit 7, adding, subtracting, and multiplying them. Special products, that's multiplication. So special multiplication, special meanings, some special cases, and you could do them the old way. Name, date, period. Let's label your notes, put the title on it, put your name. Okay, so we could do these problems the old way. In fact, I'm going to start it that way. So let's do example 1. You could actually do all these problems without anything new, but these new things are going to make it quicker. So x plus 8 squared. Now, the way we would do this is we say, oh, well, x plus 8 squared is x plus 8 times x plus 8, right? That's what it means for something to be squared. And then we could distribute. FOIL, distribute. I like to just think distribute. Right? So we do x times x is x squared. X times 8 is 8x. 8 times x is 8x. 8 times 8 is 64. And then we combine like terms to simplify it. So we get x squared plus 16x plus 64. And that is the correct answer. Okay? But there is a pattern here. Okay? What you might notice, so I'm going to do the same problem again, different way. This way I'm actually just go straight to the answer. You'll notice that this first term right here is just the first thing here squared. In the middle, we have 8x and 8x, so we have 2 of these, and you put an x in there, and you put an 8, and the last thing is just going to be the last thing squared. So that's the pattern, and we get the same answer, x squared plus 16x plus 64. Okay? So we just did the problem twice. Now let's write down what the pattern is, what the formula is. Square of a binomial pattern. Binomial is 2-term, right? Square means they're squaring it. Now there's sort of 2 versions. There's A plus B, so this is very generic with just letters where we would usually have numbers and things like that. The pattern is, it's the first thing squared. In the middle, you add 2 of both of these times each other, plus the last thing is the last thing right here squared. Okay? We can do the same thing for subtraction. They call it, this is called a sum, binomial sum squared. This is the difference. Binomial difference is your subtraction. Now, we could really, the pattern looks like this. It's a squared minus 2ab plus b squared. So you could say, okay, well, if it's minus, this is going to be minus. Now, this last one's always plus. If it's plus, this is going to be plus. Okay? I kind of think of them as the same pattern. If there's a minus, I just plug the minus in the parentheses. So let's do another example. Example 2. We're going to do a couple. X plus 5 squared. So using the shortcut, we know it's going to be the first thing squared plus 2 times the first thing times the second thing plus the second thing squared. So that's the pattern, and we just plug it in. Well, we plug in x here. Here it's an x and a 5, and then a 5 here. And our final answer is x squared plus 10x. 2 times x times 5 is 10x plus 25. So we could do it like that. So that's using pattern. Of course, we could always just do it the regular way, which honestly, I probably do it that way myself. To me, this is a shortcut, but not much of a shortcut. Let's do another one. 2x minus 3 squared. Now, this one's a difference, so this one has subtraction in it. And so, to me, I think of it the same. It's going to be the first thing squared plus 2 times the first and second thing plus the last thing squared. So to me, it's the same pattern. I put a 2x here, I put a 2x here, I put a negative 3 there, and a negative 3 there. So now when you square this, the 2 gets squared and the x is squared. So that's 4x squared. 2 times 2 is 4, times 3 is 12, so it's minus 12x plus negative 3 squared is positive 9. Negative 3 times negative 3 is positive 9. And that gives you the right answer. Alternatively, you can put a minus here and then not put the negatives in here, and that works also, but I don't know. It's kind of up to you guys. I mean, I kind of like to think of it as the same pattern. Now, one thing I want to point out that some people think might be true is that you can distribute exponents into addition and subtraction and get this. I mean, even my calculus students do this silly error. Or that you could do it like this. You could distribute it into a difference. You cannot distribute exponents into sums and differences. Never. Never do that. Okay? There's going to be a middle term. The middle term will come out of this. First inner, outer, last. If you do this, you're ignoring the inner and outer. You're just doing F and L and FOIL. Okay. Now, there's another case. Okay? So we'll call this example 3. So here's a different special case. X plus 3 times x minus 3. They call this the sum and difference pattern. Sum is addition, difference is subtraction. Now we could do this the way we've always been doing it. We could distribute. X times x is x squared. X times minus 3 is minus 3x. 3 times x is 3x. 3 times negative 3 is negative 9. And look what happens. These two guys cancel each other out. You have 0 x's. Negative 3 of something plus 3 something. There's none left. And your final answer is just x squared plus 9. Okay? Now, this shortcut, I think, is definitely worth it. Okay? The shortcut is that the middle terms, if you have the same exact thing, same thing, but the only difference is the plus and the minus, they call that the sum and difference pattern. And in that scenario, the middle terms are always going to cancel each other out. So you're just going to get the first terms. Okay, so anytime you have this, the two middle terms are going to cancel out. So you could just do first, x times x is x squared. And then last, 3 times negative 3 is minus 9. And you just get the answer right away. Now, to me, that's worth it. Now, really, what you could think of this as is it's the first thing squared minus the second thing squared. It's x squared minus 3 squared. You get x squared minus 9. Okay? So this is sum and difference pattern. So let's write down the formula for it. Sum and difference pattern. Sum and difference pattern. Okay? And sum difference pattern looks like this. A plus B, A minus B. Now, it doesn't matter if the plus comes first and then the minus and the plus. It doesn't matter. But the formula is that you just get A squared minus B squared. So that's pretty good. I think I like that. I like that one a lot more than the other one. I feel like this one's a lot more helpful. Let's try a few more examples of both of these, but we'll start with the sum and difference pattern. So example 4, let's do n plus 4, n minus 4. So the way you can think about it is you can say it's this It's just first and last. You skip the inner and outer. Or you could think of it as the first thing squared minus the second thing squared. N squared minus 4 squared. N squared minus 16. Okay? This is when it's a plus and a minus. Let's do another one. 5x minus 2, 5x plus 2. So this one has the minus first. Doesn't matter. Okay, it's a sum and difference part. They got to be exactly the same, but one's minus, one's plus. So we could say 5x squared minus 2 squared. 25x squared minus 4. Okay. Let's. I'm gonna get another piece of paper, and we're gonna do just a few more examples, just to really make sure we got the hang of this. So we'll call this example 5. Now, if you feel like you're getting the hang of this, pause the video and try it yourself. So we're going to do x plus 7 squared. Okay? Pause the video, see if you can pull it off. Now, this is that first pattern. This is not the sum of difference pattern. This is the square. Okay? So on this one, we do the first thing squared plus 2 times the first and the second thing plus the last thing squared. And then you could plug it in x, 7, 7. So the answer is x squared plus 2x 7 plus 14, 14x plus 49. And remember, you can do all these problems without any of these shortcuts today. So you don't have to get scared. I mean, it's nice if you learn the shortcuts. Okay, let's try another one. So that's a difference, binomial difference squared. It's not the sum of difference pattern. Middle terms don't cancel out. Squared plus 2 times first, second, plus last thing squared. 2w, 2w, negative 3, negative 3. Do that, you get 4w squared. 4 times 3 is negative 12w minus 12w plus 9. All right. Let's try. Okay, so this one right here, the directions are going to be like this. So we're going to try these. All right, you can pause the video. The directions are find the product. You probably don't even need to say that. They're going to give you something that is a product. So 5p plus 2 squared. And then we're going to do 2x minus 1 squared. And then we're going to do 4x plus 1, 4x minus 1. So pause the video and try these. See how you do. Okay, assuming you tried all these on your own, this is a square of a binomial. So it's the first thing squared plus 2 times the first thing, the second thing, plus the second thing squared. It's that pattern. 5p, 5p, 2, 2. So it's going to be 25p squared. You do distribute the exponent into multiplication and division. You can't do it in addition and subtraction. It's going to be 10 times 2. This is going to be 20p plus 4. This one, this is another sum of a square of binomial. So it's going to be the first thing squared plus 2 times the first thing, second thing, and then the last thing squared. It's going to be 2x, 2x, minus 1, minus 1. It's going to be 4x squared minus 4x plus 1. Last one is the sum and difference pattern. So it's going to be the first thing squared minus the second thing squared. 4x, 1. 16x squared minus 1. So we have essentially two patterns. We have these two, but it's the same pattern essentially, right? Square of a binomial, shortcut, and then the sum of the difference pattern. This one's a super shortcut because you essentially ignore the middle terms because you know they're going to cancel out. That's why we do it, because we know they're going to cancel out. You could do the work if you're not sure. Today's assignment, classwork, monitoring progress. Out of your textbook, page 372, problems 1 through 8 all. If you do it in the student dynamic ebook, there's little blue arrow buttons next to each problem. If you're zoomed all the way out, you play it, plays a video that shows exactly how to do that problem. And you can check your answer or figure out how to do it before this week's assignment for this unit. All right, do your best.